Hello friends, welcome back to Beyond Pipelines 103 Part 2. Today we are going to see the pipeline system details and the various elements involved in the pipeline system, which will give you the more clarity about what exactly are the elements in the pipeline and what it consists of. And then in the future series, then the further details can be discussed. This is going to be very important lecture for the beginners who wants to know what are the various elements of pipeline system, because at the moment they might be just hearing about the pipeline, but what exactly it has got, various parts and important aspects about it. So you will find out in this lecture. Let's begin. So the background and introduction to part 2, if we just want to recap what we have seen so far. So we have seen the types of pipelines in 103 part 1. Then we have seen the typical pipeline system. What we are going to discuss today applies to most of these pipelines. We have seen flow lines, trunk lines, bulk lines, loop lines, gas export network. So these are different names, but basically they need to be designed with all these elements. Depending upon the type of pipeline and the material of the pipeline and its application and criticality, some elements may not be required. Like for example, if we are talking about the corrosion monitoring, then that may not be required for the non-metallic pipelines like GRE. Whereas the metallic pipelines like isolation joints and things like that will be required for the metallic pipelines where the CP current is involved. So these are just the examples. We'll see them in detail later. So we also should know basically about the difference between piping and pipeline, because many people are confused about piping and pipeline. They think that it is same, and if you see the code titles, many times code also talks about piping systems, even though it is for the pipeline, like 31.8, 31.4. So ASME, of course, ASME B31.8 and 4. So it is important to quickly see what is the basic difference between piping and pipeline. So you can see these two small pictures here, in which the first picture shows the plant or facility in which the lot of pipes can be seen, pipe rack, tanks and columns and vessels, and it connected with multiple pipes. This is called piping, which is part of the plant facility. Within that fence area, the piping is covered. Whereas the second tiny picture is showing the pipes laid on the ground and running long distance. They are normally cross country or intra-field pipelines where they transport the fluid from one facility to other facility, one treatment plant to other, or from the gathering system to the plant, or the export network, which we have seen in 103 part 1. So that is what is the basic difference. Like treatment or processing facility or plant involves piping, and the transportation from one facility to other or the export network involves pipeline. Now we'll move to the pipeline, because our series is mainly for the pipeline design and the related aspects. So we are going to see a typical pipeline system first, which shows majority of these elements, which we are going to discuss in detail later. So let us start with the basic pipeline system, or typical pipeline system, let's call it. So this picture shows the a typical pipeline system, which involves a lot of ancillary elements. It has got mainly launcher and receiver, which is called pig or scraper launcher and scraper receiver. We will discuss about it in detail later, but just to brief you, pipeline is transporting the fluids, and it is laid for very very long distance. Okay, and it needs to be maintained because through the fluids it is transporting, there could be some deposition of the solid particles, or some deposition happening inside the pipe diameter, inside the pipeline. Some of that could be also stagnant water or liquids getting saturated or getting stagnant in the low points along the pipeline, because when pipeline is laid from say one city to other city, it has to cross, or it has to go via the terrain, the elevation profile of that land. It can be having small hills, low points, valleys. It will go through all these points, and therefore pipeline will have natural low and high points. And at these low points, the stagnation of the liquid or water can happen, and then this can start a corrosion reaction at the 6 o'clock position in the pipeline. So to overcome that, the pipeline requires some kind of a measures like chemical inhibition, which should form a film inside the pipe, which will avoid or minimize the start of the corrosion at such locations, critical locations in the pipeline. And also the pigging, or scraper. So you can imagine that a piece of metal with brushes connected to it, or wires connected to it, uh, is passed through the pipeline, and it will clear all these such deposits, and it will also push all the liquid which is getting stagnant at the low points, which will push it to the other end of the pipeline. So this is called pigging, and it is basically cleaning the pipeline in a way, indirectly. So if for the beginners, you can consider this as a cleaning of the pipeline, and which is done at regular intervals, so that the pipeline remains clean, and the corrosion remains under control and predictable. So there are different methods also for the corrosion measurement and protection, which we'll cover later. But to be able to insert the pig, because you can't stop the operational flow of the pipeline so frequently. Otherwise, if that happens, then you will be having stoppage, or intermittent kind of a disturbance in your flow, which is not ideal situation. So what is done is the pig is passed or pushed with the same service fluid which pipeline is transporting. So pig has to be inserted in the live pipeline along with the flow, such that it can go along with the flow, and by doing that it will just scrap the deposits and push the stagnant liquids away. So to do that, we need a pig launcher, and to receive the pig, it requires pig receiver. So what pig launcher is going to do is, it has got the isolation valve, and it is connected at the end of the pipeline. So the service fluid which is connecting from the gathering system or one plant, or the plant export at the outlet of the plant, which pipeline is going to transport, is normally connected through a T, and it is not connected to the end of the pipeline, but it is at the branch of the pipeline, which is called the bypass piping, and bypass line, which is shown here as a bypass line in this sketch, or in this picture. And it is mentioned that it is from well or treatment facility. So from there, the main stream is going to be connected by means of the mainline bypass valve, and then the on the left side of that you will see launcher, which is major barrel, and some connections and valves and all that, and with the bypass pipe is connected to the main pipeline with the help of bar T. I will explain what is bar T and what is the difference between bar T and normal T to explain. So what happens is, when you want to push the pig in the service fluid along with the service fluid of the pipeline, what happens is you insert the pig in the launch barrel, Launch barrel is isolated from the main pipeline by the isolation valve, which is closed, and the launch barrel is empty and also free of hydrocarbon. So you can open the pig trap closure end cap. By opening that, you insert the required pig that you want to launch in the barrel. You close the end cap or the end closure. Then what you do is, there is a kicker valve shown. There is a pipe you can see connected to the barrel. So temporarily, to launch the pig from the barrel to the main pipeline, what you simply do is you open the kicker valve and you close the mainline bypass valve. So your flow automatically gets diverted through the barrel to the pipeline now, and then you are going to open the isolation valve of the pipeline, which is isolation valve, which is also called mainline valve, which is between the launcher barrel and the pipeline. Okay, this valve is between the barrel and bar T, you can see in this sketch. So by opening that, what happens is your flow is now diverted through the kicker line to the barrel, and then that flow will push the pig from the barrel to the main pipeline, and it will go along with the flow. And once it is launched, then your use of launch barrel is over. So you simply close the kicker valve, open the mainline bypass valve, isolate the pig trap barrel by closing the mainline isolation valve, or which is shown here, and then you can once again depressurize the launcher. You can do the necessary cleaning of the launcher, and then you can keep it filled with nitrogen, so that because it is going to have otherwise the dead fluids, dead hydrocarbons, which can be corrosive most of the times. So you can keep it clean with purged with nitrogen, so that the corrosion is prevented in the barrel. So the pig is launched, and then it goes along the pipeline kilometers long. Okay, cross country pipelines sometimes can be even 300, 400, 700 kilometer long. So it passes through that. Of course, if it is very long pipeline, then normally at the one pig run is kept limited to 100 to 150 meters, because pig is going to wear and tear while it goes because of the friction between the pipe and the pig. So the pig, once it reaches to the other end of the pipeline, which is equipped with receiver, pig receiver. So you do exactly opposite what you did while launching the pig. What you do is, you again open the isolation valve, mainline valve, so that you create a path, flow path to the receiver barrel. You open the kicker valve, which is also shown, and you close the bypass valve, so that now your pipeline flow, which was otherwise going via bypass valve, bypass line to the other treatment or export facility, now it is routed through the barrel and via kicker line to the same location, to the same facility. So by diverting that, what happens is, your pig will go and enter the receiver barrel, and once it enters, you can see some pig signal mentioned there in the sketch. So what happens is, when the pig passes through that point, the pig signaler will indicate that the pig has passed, and that means your pig has cleared the mainline valve, it has entered the receiver barrel, and then you can open the bypass valve again, you can close the kicker valve, you can close the pig trap isolation valve or receiver isolation valve, mainline valve, and then your flow will normal flow will continue through the bypass line to the treatment or export facility. So basically, from bypass to bypass, at the start point and end point, the flow will continue. Whereas your receiver barrel also is isolated from the main line, so you depressurize it. You after depressurizing and draining, you open the end closure of the receiver barrel, and then you can pull your pig out. Along with that, all the dirt and sludge and mud is going to also come out, and the whatever slurries and the kind of a carbon steel pipe rust can also come out, which is also called scalp, that also can come out. So you can just remove all that, clean the receiver barrel, make it free of hydrocarbon, purge it with nitrogen, close the enclosure, and keep it preserved with nitrogen to avoid the any corrosion reaction to take place.